I think I've drawn the short straw, and I am now the graveyard shift, the final presentation, so I will try and make this quick. What I'm going to do today is present Work Package 4, Implementation T2, which you don't need to know about, that's an Interreg thing, of the Interreg project CatchmentCare, which finalised last year in 2023. The work that I'm going to present is the work of multiple partners, ourselves at Loughs Agency, Inland Fisheries Ireland, Armagh, Banbridge and Craigavon Borough Council, Ulster University and Donegal County Council. So the overall aims of CatchmentCare are up here. They were to improve freshwater quality in the cross-border river basins across 3 catchments, the Finn, the Arnie and the Blackwater, through the use of development of 3 water quality improvement projects. So I'm really sorry about the slide between the slides. I don't know why that animation is doing that, and I can't make it stop doing that. So the water body actions and catchment work centred around improving water quality using WFD status as a proxy for water quality in these priority areas, and it was focused on water bodies which were failing to achieve good ecological status under WFD. And what I want to do today is talk to you about the in-stream works, the riparian works, and the control of chemical export works from land use. But I wanted this presentation to not just be about the work that we delivered, but also the lessons that we learned, primarily around evidence bases for targeted prioritisation of works. Oh, that slide between those is horrible. So, as I'm sure you all know, our freshwater systems are under extreme pressure from anthropogenic activities, both now and historically. And largely, pressures can be kind of grouped into these sort of 8 categories. So diffuse, things like pollutants and contaminants, which enter the surface and the groundwater through diffuse pathways like runoff and rainfall. Point, so contamination from fixed identifiable sources like wastewater treatment plant. Hydrological alterations, so where humans have changed the flow and the patterns and the hydrological regimes. Abstraction, where we are constantly removing water from our freshwater systems for all the various things that we need water for. Barriers, which we've had some discussion about already today, which reduce connectivity not just for animals but also for sediment and nutrient. Physical alterations to the channel, riparian zones and surrounding floodplains for agriculture and for urban development, amongst other things. Introduced non-native species lead to things like habitat competition, habitat alterations, hybridization and predation. And climate change, just to add to the additional never-ending list of pressures, leading to changes such as increased water temperature, flooding, drought and eutrophication. I think the important thing to remember is that these pressures are not happening kind of mutually exclusive. They're often all happening on top of each other in the one system. And that means that from a restoration point of view, there's no real one-size-fits-all, because the sheer number of pressures on our freshwater systems means that we get to this whole host of impacts, such as biodiversity loss, reductions, and water quality impacts. So, with all of these pressures recognised, we can understand that in order to improve water quality, we need to work towards restoring our water bodies to as close to their natural state as possible, so that the rivers can do what they are designed to do. When we talk about restoration, essentially what we mean is the re-establishment of natural functions of the water body related to the physical, chemical, biological processes, and importantly, the linkages between the terrestrial and aquatic ecosystems. So we're aiming to repair the diversity and dynamics of our aquatic ecosystems in order to ensure that natural processes are essentially operating efficiently. This process needs to be robust enough to be long-term, to build resilience in our systems so that they can cope with the multitude of pressures that they're up against. Sometimes it's possible to remove the pressures. More often than not, it's not, but we have to simply try and mitigate against them as best we possibly can. This is the theory bit. I'll try not to go into it too much, but from the point of installation of a habitat restoration work, the assumption is that change will occur. That's what we want. If our original assessment of the situation is correct, and we have chosen the correct remediation, change should be positive, we hope. Positive changes could be short-term, they could be immediate, they could be medium-term, they could be long-term. Some intervention measures could provide short-term changes, which then become medium-term and so on and so on. Or the immediate measure may introduce a short-term positive change, but quickly revert to the original problem due to some unforeseen issue or a new pressure being introduced. Worse than that, there is always the possibility that a remediation measure may actually lead to a short, medium, or long-term negative change. Again, due to unforeseen issues, obviously none of us are going out to try and, put across a negative change, but we can take nothing for granted, and that has to be considered as a possibility every time we work in the river. So the point that I'm trying to get at here is without appropriate monitoring and assessment of our sites after work, it's basically impossible to track the extent or direction of changes in the river environment. So if we want to be able to track the changes, we need to appropriately baseline. And really, in order to evaluate success, it's really important to understand two things. One, what parameters are we measuring and what represents success? And two, how decisions on what remediation works we do were arrived at in the first instance. A lot of time for river restoration remediation works, they're sort of selected based on available funding or in response to some catastrophic event that triggered the need, like a flood event or similar. In the case of CatchmentCare, we were in a slightly different position in that we were able to assess entire catchments and prioritise sites for work based on things like electrofishing surveys, rat surveys, barrier surveys, and in the case of the Finn catchment, macroinvertebrate surveys. So this actually allowed us to create a scoring and selection matrix, which is like the stuff of dreams for those of us who do this on a day-to-day basis. We were able to take these results, work through the sites largely in order of priority. And this gave us a set of baseline parameters for each site upon which we could monitor change. So this is a map of the prioritised site on the Finn. We did the same for the Arnie and for the Blackwater. And having these sort of pre-work surveys, I guess, put the CatchmentCare in a really good position to monitor change after work, as we had a really clear baseline as what it was we were measuring against. So the first of the restoration techniques employed by CatchmentCare in the Finn, the Arnie and the Blackwater was in-stream restoration. So this is work that aims to restore the biotic and abiotic elements of the river itself. So we were aiming to use ecosystem-based approaches to restore the habitat by reducing flow, creating more dynamic habitats, adding natural complexity, linking systems where human activity has reduced connectivity, and reducing the impact of erosion where it is unnatural, and encouraging sediment trapping, because it is important to remember that erosion is still a natural process. So in CatchmentCare, what we tried to do was employ what are called green engineering solutions. So where possible, we favoured the implementation of nature-based solutions. This approach was designed to improve longevity through natural resilience and is consistent with the Sustainable Development Goals, which we kind of hope everything is nowadays. In CatchmentCare, over this space of the 5 years, 4.5 years, I don't know, some of it was lost to COVID. In CatchmentCare, we delivered 130 in-stream works across the 3 catchments. This work included the removal of 2 major barriers to fish migration, pinning of woody material at 28 sites, over 80 kilometres of bank stabilisation, and a large array of other techniques at multiple sites, including the installation of willow weave walls, gravel cleaning, rubble mat installation, creation of meander complexes, pools and riffles. This was a huge amount of work, and I cannot cover it in one slide. So I have a link at the end to the storyboards that were created for each of these sites so that you can go in and see more about what we did in depth. As we've kind of already chatted about, river restoration in CatchmentCare required us not only to look at the water itself, but the linkages between the aquatic and the terrestrial habitats. With that in mind, riparian restoration was a major part of the focus on this project. For all 3 catchments, the major pressures come from agricultural interactions. And so riparian restoration was really of key importance. We largely focused on the creation of buffers between the land use and the rivers, and this involved using fencing to keep livestock out of the rivers. Tree planting was also a huge part of this work, so we planted deciduous broadleaf trees, which provided an array of benefits to the river, the land, and the land-river interface. By providing structural integrity to the banks, shade to the river, acting as a buffer to land runoff, and providing vital nutrients to the lower trophic levels in the streams through leaf litter and branch drops. The creation of fences and buffer strips removes the impact of livestock poaching and trampling of the riverbed, but it does somewhat pose a problem for landowners in providing water for their stock. A lot of, particularly in the hill farms, a lot of water for livestock is provided by, fresh water drinking directly from the rivers. So a major part of the work on CatchmentCare was the provision of offline drinking solutions, such as solar pump supplied troughs. Landowners also still needed to have access to the riparian buffer strips, so gates and stiles were a really important part of this work. Again, this is a single slide to represent an enormous amount of work over 3 catchments in 5 years. But CatchmentCare, we created nearly 100 kilometres of new riparian buffer strips across the 3 catchments. We also installed literally hundreds of gates and stiles, 455 offline drinking solutions for livestock. And the project, and this is kind of a personal gold star for me, is also responsible for planting well over 30,000 native broadleaf trees across the catchments. So the Finn had a slightly separate issue to the Arnie and the Blackwater in that in the Finn, many sites are failing to meet good ecological status under WAFD as a result of poor macroinvertebrate EQR scores. CatchmentCare aimed to address this by looking at chemical export from land use, which we considered at the outset of this project to be the major source of the issue. Chemical export from land can affect both surface and groundwaters and has significant impacts on ecosystem conservation as well as human health. Chemical export has a number of potential impacts to the receiving water body, including macroinvertebrate mortality, fish mortality, potential ecosystem collapse, and species and behavioural changes. In the Finn, there were sort of considered 2 probable major sources of chemical export. One was sheep dipping practices, and the other came from forestry. So the team started by kind of investigating the issue at a kind of literature-based level, because these were all ecologists and biologists and not biochemists by any stretch of the imagination. The baselining work found that acetamiprid, cypermethrin, a range of organophosphates, as well as MCPA, were probably the most likely culprits contributing to chemical export issues in the Finn. The baseline work also concluded that while forestry probably historically would have been a major input, nowadays probably isn't. A lot of that had already been addressed. So we focused our attention on sheep dipping practices. The Finn, just for a little bit of context, is largely hill farming for sheep. We knew of 41, I think, sheep dipping points on the Finn. We came back with over 100. So there was a considerably more input than we even sort of thought we knew from a base level. So much of this work, the mitigation work, was based around awareness raising and education. We worked really closely with the farming community and with Teagasc, completed questionnaires, we produced infographics. All of these are on our website. If they're any use to anybody, please disseminate them. We did advisory sheets and a really nice educational video. The work was really successful and totally relied on us having a really good working relationship between the stakeholders on the Finn and the project. We also had to do some science. So we used some novel techniques to detect and quantify the presence of herbicides and pesticides in the Finn. And we did this using an integrated system of passive samplers, which you can see here, ChemCatcher base, sort of. And we deployed these at 5 sites across the Finn catchment and used them to try and detect herbicides and pesticides in the water column over the space of a year. In slightly terrifying results from it. The site that we chose as our control site, because it wasn't near any forestry or sheep dipping, also brought up traces of all of these chemicals. So it just goes to show you how prevalent these chemicals are in the system, and it's not necessarily that simple to link them directly to source. We also, so Loughs Agency in collaboration with Donegal County Council also installed 3 integrated constructed wetlands. The ICWs were designed essentially to act as huge filters, effectively trapping chemicals from the publicly used sheep dipping facilities. This was another exemplar project where CatchmentCare used nature-based solutions to address catchment pressures. So if we go back to this slide, and we've now talked about this in a kind of complex manner, we now realise that the potential outcomes in terms of change from any remediation project are even more complex, as each individual element of a remediation works could have positive or negative effects over various timescales, and could also have cumulative positive and or negative effects over various timescales as well. I will admit that if we actually thought about this, we probably wouldn't sleep, let alone do anything at all, but we have to do something. So we sort of have to layer the potential changes. So I was kind of largely grouping them in terms of physical changes, environmental changes, and hydromorphological changes. I think this was the big learning out of CatchmentCare, was not only the need for baselining, but the need to build in long-term monitoring and assessment. This is absolutely essential in order to provide rigorous post-project assessment and evaluation. But the assessment work needs to allow us to examine the impacts on appropriate temporal and spatial scales in order to account for the various life history traits of the organisms that we're trying to protect. For example, if we finished works in November, there wouldn't be a whole lot of point in doing a macro-invert survey in November and then never looking at it again, because that would not allow us to appropriately monitor change. We need to continuously assess the integrity of the works as well. A lot of the works that we're doing is fairly novel and fairly new. So we need to be able to account for any potential maintenance issues which may cause secondary negative impacts if they're not addressed. Continuous assessment also allows us to critique the effectiveness of techniques over time, which will all streamline the process and inform decision-making in the future. Essentially, what we want is to get to the point where we can allow for qualitative and quantitative assessment of long-term performance. We also need to be aware of new and emerging threats and pressures which may not have been really accounted for in the original assessment of the site. So we need to be able to account for how any restoration works we do may be behaving against a new pressure in the system and act accordingly, climate change being the obvious one here. I have highlighted, I don't know if you can see at the bottom of the screen, mechanism to review the validity of original conclusions. This tends to be the main reason that any of us do any evaluation work. And whilst it is a valid reason for monitoring, it is not the sole reason. And unfortunately, with the way that many of these projects are set up, monitoring tends to be sort of within a time frame. It tends to be pretty immediately after the work is done, and it doesn't allow for any sort of data gathering that is required to meet all of the needs that we've just previously talked about over appropriate timescales. So I think I made the point, hopefully, about the need for baselining and monitoring and assessment of river restoration works, but as we all know, need and capacity are not the same thing. And there are a huge number of issues around monitoring and assessment that really don't have easy answers. But my kind of mission here today is for any of you that are creating new projects or starting to work on Peace Plus projects or whatever, that you think about how you build in for baselining and for continuous assessment, and that you're appropriately resourced to do that on appropriate scales. So I've listed here terrifying requirements that need to be built in. Obviously, capacity and resourcing of continuous assessment is pretty much the big stumbling block that we're all up against. The frequency of post-project monitoring is very much project dependent, but it is something that should be front-loaded into projects, even if it's just legacy work that individual partners commit to take on after the lifestyle of the project. I've also listed a few other requirements for consideration, not least expectation around maintenance responsibilities for things like fencing and tree management, etc., and how managers' views line up with landowner views on these issues. These are definitely lessons learned from this work. The other issue with all of this is that in order for this to become a holistic approach, there is a need for some sort of data storage, sharing, dissemination platform where the various agencies carrying out this work can learn from existing projects and what works and what doesn't work as a mechanism essentially to reduce effort for all of us in the long term. I'm aware that really all I have done here is listed a bunch of issues and provided very little in the way of solutions. But I do think it's worth highlighting these, and it's worth noting that these are things that need to be considered from the outset of any river restoration project in order to truly execute what can be properly described as an evidence-based approach to restoring river habitats. Thank you. I've gone under time, which is a miracle. Please look at the storyboards on the CatchmentCare website for more information on the ins and outs of the actual projects.